So where I left off, I was very messily writing this third type of probability problem, where we draw this large circle in whatever color you like, and then we draw a smaller circle someplace on it. You can vary the size of the circles as long as they both fit. And then we give them some information about each of the circles so that we can figure out their area. So in that problem, we said the radius of the larger circle is 5, say, inches or units or whatever. The diameter of the smaller circle is 1 inch or whatever. And then a point is selected at random from the larger circle. What is the probability that the point lies in the smaller circle? And we could have given them the diameter, the radius, the circumference, or maybe even directly the area of each of these. So that's one thing that you could vary if you like. So this is really kind of testing students' abilities to kind of do radius and circumference and all of that. So for this particular problem, the first hint would be the area of the larger circle is 4 pi times 5 squared, which is equal to, and we're going to assume that they've already done the basic geometry module. So this is what? This is 4 times 25, which is equal to 100 pi. And then we say the area of the smaller circle is, well, its diameter is 1 inch, so its radius is half an inch, is 4 pi times 1/2 squared, which is equal to, well, 1/4 of 4, which is just going to be equal to pi. So the probability is, and then we could even do this in this color. So if that's that color, so that's pi. So the probability is pi over, this could have been in 100 pi if you like. Don't worry about it if that's too much trouble, because the same color as this outside. We could color it all out like that. So the probability is pi over 100 pi, or 1 in 100. Or 1 in 100. And obviously, we'd put all different choices that properly allow us, that might confuse students, or that might be reasonable things to pick if you didn't know how to do this problem. And if you want, we could also, it doesn't have to just be circles. It could be a small square inside of a big circle. It could be a small circle inside of a big square. If we want to get really fancy, we could have multiple small circles that maybe have the same radius, and so then the probability would be twice as much. But I think all of that is fair game. Now, I've already shown you 3 types of problems in this probability 1 module. Let's go for a fourth, just because I think this is a bit of a classic problem. Edit clear. And so the last one, the fourth type of problem in this intro to probability, and they all have the same basic principle of counting all of the possibilities and then picking the subset of the possibilities that meet your constraints. So let's say we have a bag. With 3, and we can make up the numbers here, 3 blue marbles. 5 red marbles. And 2 yellow marbles. What is the probability of randomly selecting, and then you could pick one, a yellow marble from the bag? Now here, if you want, you could just do a text base, or you could say the first time they click hint, you could literally you could draw the 3 blue marbles, 5 red marbles. This is if we have more time. Otherwise, you could just write in text the 5 red marbles, and then you have your 2 yellow marbles, and the hint could be here, are the, how many is that? 10 marbles. 10 marbles, and you could change that number. Marbles in the 10 possible marbles to pick from. The 10 possible marble choices. And then we could say, two of them are, or two of the 10 are yellow. And if we want, we can, let me just copy and paste that. Copy, and then we paste it. And if you don't want to, we don't have to draw circles here. You could just write a blue, the letter, a caps B in maybe a blue color, and then a caps R in a red color, and then a caps Y in a yellow color if you want. 2 of the 10 are yellow, and then you can just underline them or do whatever you think highlights them best. So it would be something like this. So you say, so the probability is 2 out of 10 or 1 out of 5. And obviously, we put the appropriate choices. So this is a little bit more involved module. We have 4 different types of probability problems, but they're all fundamentally testing the same thing, but they're doing it from a slightly different angle or a different way of thinking about it. But I think it's really important to expose students in all the different ways. And as the developer, feel free to change as much or as little as you like, or put more variations. I mean, this was a probability of a yellow marble. We could ask for the probability of a blue or a red. You could even ask for the probability of a non-yellow marble. So you would say, oh, all of these meet the conditions. So as much variation as you'd like to put into the module.